What's going on, guys? It's K-Dub here with another episode of Crypto Zombie. Today I have a very special guest with me. I have Ziqi Chen, the CEO of Cortex. How's it going?
Hi, Kyle. I'm pretty good.
Awesome, awesome. So basically, just to kind of get it out of the way, just in a nutshell, what is Cortex?
Okay. So I will start to introduce the background of Cortex and how we formed these labs and this project. Basically, we were a group of veterans in cryptocurrencies for many years. Among our three co-founders, me, Ziqi Chen, and our CTO, Wei Yang Wang, and we have a chief scientist, Tian Jia. Um, we mined Bitcoin from pretty early days. So Tian Jia mined Bitcoin from 2011, and for me, I personally mined from 2013. And we have done trading, digital wallets, and the mining pool. So we are pretty familiar with this ecosystem, exchange, trading, digital wallets, all these kind of things. Back into 2016, we met with each other to talk about the idea, how can we bring AI on blockchain? So, there are a lot of ideas talking about this to combine this together, but the way we are doing is pretty unique. So this is actually, the solution is actually um, is discussed a lot. We have an internal debate. How are we going to do this in terms of the technical solution? So until the beginning of 2018, we started the ICO. So that's the whole story of this project.
All right, awesome. So, well, can you just for people who don't know what it actually is, can you just tell us what is Cortex exactly?
Oh, yes. So Cortex is a public chain. It's like Bitcoin and Ethereum. It's the fundamental infrastructure for the future computing.
Hmm.
Instead of dealing with the scaling issue, the TPS issue, we are pretty much focusing on a computing power issue. It's not it's now using AI training to replace the POW in the cryptocurrency mining. We are actually focusing on the AI inference. So for people who may heard about artificial intelligence, um, might know for AI, there are two domains. One is training, one is inference. So the training process is quite simple. You collect data, you run your algorithm. That's the process for training. So for inference is once you get the model from the algorithm, because once you run your algorithm, you get the model. You get the model, you use your model to do infer when you are in each scenario. So industry believe it has a larger market in this domain compared to training, because the training is pretty much dedicated for researchers and the developers.
Hmm.
So for what we are doing is bring AI inference within the smart contract layer.
Mm-hmm.
So for the current smart contract in Ethereum, you write a smart contract, the logic is pretty rigid and the computing process is quite simple. Ethereum virtual machine doesn't support complex computing. So what our contribution is bring this to the next level.
Hmm.
So within smart contract, you can do very complex computing, including AI algorithm. So let me give you an example. Is for the previous generation of iPhone, you use passcode to unlock your screen, right?
Right.
So now you unlock your screen using your face. So it's a face recognition. But the face recognition process is actually computing intensive. It will recognize every pixel, from the camera, and do the computing on each pixel.
Mm-hmm.
So this cannot be run on the CPU of the iPhone.
Right.
So the new iPhone doing the facial recognition, it comes with a dedicated chip. That's a FPGA chip, can run AI algorithm. So what we are doing is bring the smart contract layer running on GPU or FPGA instead of a CPU, because CPU cannot handle those computing power.
Mm-hmm.
That's the main point.
Yeah, I was going to ask you. So you're basically saying that currently the smart contracts aren't good enough. So you're aiming to expand the possibilities of smart contracts and blockchain. Essentially, you're making a smarter smart contract. So
Yes.
can you kind of elaborate, go into detail some of the aspects of that? How are you really going to make these smart contracts, smarter, essentially?
Oh, yes, sure. Do you want me to go to very deep in technical or just?
No. I mean, you could just basically talk about some of the key features. I mean, I know you guys stress inference a lot.
Yes,
you have
yes.
your Cortex inference consensus criteria. You could kind of go into
Yes.
that. Yeah, I mean, I'm trying to understand how it works. And what I really want to know is what makes you guys so different from all these other AI projects out there right now,
Okay. So from a bigger picture, so we are making inference on blockchain, and we believe um, the core value. Let's revisit the blockchain core value a little bit, because if you look at the history of Bitcoin, if you look at the history of Ethereum, so why people believe in Bitcoin? It's quite simple. If you are talking about the efficiency and processing speed comparing to a central bank is always better than blockchain so far. It's very fast. But why people believe in Bitcoin is really because of the power of the control the ledger book. So people do not believe bank. That's the key feature. So if you have a deposit and withdraw and all transaction, everything has to be transparent and recorded on a ledger book, which is a public verifiable.
Mm-hmm.
That's very important. For central bank, you cannot verify those transactions. You don't know what they are doing internally. So talking about smart contract, the concept of smart contract is actually earlier than the Bitcoin. So Nick Szabo proposed this. So he was saying that why not we put a contract into electronic version that come with a form of ledger book. So each contract has to be confirmed across the network. Nobody can stop the running of the contract. That's the Turing complete and unstoppable. That's the whole story of Ethereum. So now let's take a look at the AI. So if you, let's say in your life, if you apply a loan from bank, if you buy an insurance for your car insurance, so for if you click any link on the internet, so for merchant buying the ads, the whole process is not that transparent. This process is actually a AI decision-making process. So what we are going to do is to make the model public. So the whole process of those things, apply loan, click the ads, and what else? Buying insurance, all these kind of things has to be transparent and within the ledger book level of security. That's the core value. We preserve the core value of the blockchain. And we are not talking about the training the data over the blockchain. We're not talking about that. We're only focusing on inference. So the real valuable things for AI industry is model. Of course, data is valuable, but data is like the raw mountain, or you go to mine something, the model is really like a gold bar. It's refined from all this original material. So in Cortex blockchain, we are going to store all the model. We have a storage to store all the model. We call model do. So all this model, when they do inference within Dapps, when they do computing, they have to reach agreement, we call consensus, over the whole network. That's the core value. Once they reach consensus, it's packed into the block, and nobody can revert it.
Yeah.
And nobody can work back. That's a core
yeah.
value.
I mean, absolutely. I mean, this is a crypto channel. We talk about stuff like that all the time. But okay, so you were just speaking about your consensus. Could you make it a little clearer for everybody? Because you're saying that you're using a proof of work, right? But when I was looking in your white paper, it's referred to as a cuckoo cycle proof of work. I've never heard of that before. What does that mean exactly?
Okay, so cuckoo cycle is a pretty is actually a pretty cool technology in the POW. So let me clarify a little bit first. So the POW part has nothing to do with the AI inference. So the POW part is only in charge of packaging and encrypting all the block data. So it's exactly as Ethereum. If you go to take a look at the Ethereum code, they are using Dagger Hashimoto. The algorithm is a Dagger Hashimoto.
Okay.
Now we call ET hash to encrypt each data block. But for the smart contract layer, it's just running on Ethereum virtual machine. So we are the same. So we have a Cortex virtual machine running on GPU and FPGA, and we have a POW part. That's what you are asking me.
Yeah. Before we get on that though, your Cortex virtual machine, is it still compatible with Ethereum?
Yes, it's backward compatible with the old Ethereum smart contract.
Okay. I just want to get that out of the way. We keep talking.
Yeah. So cuckoo cycle is a algorithm designed for memory hard problem, which supposed to be a balance between different hardware, mining hardware. The people in the cryptocurrencies world, they are not very happy with centralized mining, which is the current situation in the Bitcoin world. So people, in terms of the mass adoption, you need to have more people to mine on their, consuming level hardware. So everybody can participate in this domain. That's going to helpful for this market. So cuckoo cycle is supposed to be one of the hardest problem in the POW algorithm design. It's the first POW using graph theory for all this thing.
Okay.
So basically, there is a possibility people could be using a mobile device to mine.
Oh, cool. So it makes it really fair for like the average person who, can't afford to buy a ASIC farm, essentially.
Yes, exactly.
Awesome. So can we dive into the tech a little bit? I wanted to talk a little bit about, you have both software solutions and hardware solutions. So can we just talk a little bit about some of your software solutions first? We'll start there.
Yes, sure. The software solution, so in terms of the whole architecture, we have multiple parts. One part is a storage layer. So we are going to store multiple models over the blockchain. We will use existing solutions such as LibTorrent and possibly IPFS compatible, the Filecoin protocol compatible. But we will start very traditional and classical, but simple but working way, the LibTorrent way, to store the model. And in terms of the Cortex virtual machine, that's another part. There's a storage, and we have a virtual machine part. The virtual machine has to be modified based on the Ethereum virtual machine, but the process is really like you are making a electrical car instead of a gas engine.
Mm-hmm.
We are changing the core part. It's like changing the gas engine to electric car. It's not that simple. We almost change everywhere, make the code and the instruction set available on GPU and FPGA. And one of the pitfall for this engineering solution is, when you use the AI models, you could be using a float point trained model. We will use int, low fixed point int. That's a little bit of technical term. This is specific for the hardware. So the reason is, for the model, running on GPU or FPGA is a parallel processing process. So when they do parallel processing, there is a possibility of the tolerance error for floating points. So we have to use an int point. And the whole industry in AI domain is driving into that direction, using int point and quantization technology to compress the model. So the model can be, previously the model could be multiple hundreds megabytes. Now it's compressed to just 7 megabytes. It could be fit into the SDK on your cell phone. That's very cool. And the model is compressed and very, very smart. Mm-hmm. This is as smart as the float point model. So that's the one thing we need to solve. So this is a very technical things for the too much.
Yeah. I mean, do you guys have submission inference for training off chain? You were saying that, right? Why is that so important?
The submission of the model.
Off-chain.
We have a submission. So the different developer and the researchers, they can submit their model. That's the spirit of open source. So previous, people open source. Now we can make like open model. So different people, different researchers, they have different specialties. So AI researchers, they submit their model, but some other people who is good at writing Dapps, they can just matching those models. They select the best model they think the best fit for their Dapps. So there's a matching, and the different party get different benefits from the token economy. We have an incentive.
Yeah, we'll get to that in a second. Well, actually, we could talk about that right now. But I wanted to kind of talk. We talked about the software. You guys are also looking into hardware solutions as well. So what are you going to be providing in that arena? As far as hardware,
yes. So for the AI industry right now, if you want to do a good ecosystem, you have to work with hardware manufacturer. That's the whole story. So basically, we have an investor, Bitman is one of our investors, and the Supermobile. As you know, we're talking about Cuckoo Cycle. It's not that easy for them to make ASIC mining. So we are not going to work with them in terms of a centralized mining part. That's now our focus. We will work with them on the AI inference chips. That's the whole things. And the Supermobile is also very good at making AI chips. So basically, we need some hardware manufacturer to support this whole software solution. Of course, we will consider a traditional hardware manufacturer like NVIDIA and AMD, and our platform will be compatible with those existing hardware.
Is that something that you're going to have custom built for your needs, or are you going to just adapt to one of their products already?
We don't have to. So we need to work on the compatibility issues for different hardware provider. So we will just support the major hardware manufacturer.
Yeah, that's fine. I mean, we already know it works, so it's better to focus on that. So, and now getting back to what you said before, I didn't want to get off track with the hardware software, but what is the as far as the Cortex coin, the CTXC coin, what is the token model and utility? I know it's a reward for the miners, but what else does it function in the ecosystem?
Yeah, we have another term compared with the gas in Ethereum. We use the term endorphin because our product name is Cortex. It's
Yeah,
like the brand,
I like the
and
name, by the way. It's cool.
yeah, yeah, we use endorphin. It's similar to gas. So you have a smart contract. Within smart contract, you are calling a model to do AI inference. So those smart contract has to be run on each full node. So each full node run your smart contract has to be consuming a lot of computing resources. That computing resources is metered. That's the concept of gas. So how much gas you consume. Basically, if you want your dApps running across the whole network, you have to pay a small fee to the miners. So
Hmm.
that's the whole token economy. And the people who provide the AI models, they can take, they can take a dividend from this
Hmm.
payment.
So it's pretty. I mean, it's pretty standard for the most part. That's what we would expect the utility of a token to be. Um, I mean, you kind of talked about your team a little bit, but I wanted to sort of touch on the fact I saw that you have Professor Whitfield Diffie on board as an academic advisor. For everybody who doesn't know who that is, he's pretty much the inventor of the public key cryptography and the 2015 Turing Award winner, correct? So that's pretty big.
Yes.
And you have
Yes.
Bitmain as well on board. But how about the rest of your team? What credentials and experiences do you have that makes you believe that your team can actually accomplish what you're setting out to do?
Yes. So as I mentioned before, our whole team have the first-hand experience in mining digital wallets and the existing blockchain products. So basically, we were actually technical advisors for different uh, VC firms
Mm-hmm.
who is very active in the cryptocurrencies domain. So we read a lot of white papers. Uh, for cryptocurrencies world, of course, we believe we have demonstrated record in this, and everything is verifiable. People can search what mining tool we have and digital wallets. So for the AI part, I know there are some project combining AI on blockchain, but most of the project they don't have a tracking record. AI is very they put very pay attention to their ranking. So in our team, we have a tracking record in the Google Kaggle competition.
Wow.
Among the top 100 researchers over the whole world, we have 20 people already on board in this project.
Uh,
So they are very this very public information. People can go there to verify. So we have a very deep understanding in AI and the cryptocurrencies, of course. In terms of the Professor Diffie, and we will work on some fancy things to maybe use zero knowledge proof to help the smarter AI contract. The running the AI contract could be is computing intensive. People in the research domain were thinking about, can we use zero knowledge proof method to execute the contract just once and then verify in the other place. That will save a lot of time.
hmm.
That's just a research topic.
Yeah, that would
So
actually that'd be pretty interesting. Zero knowledge
yeah,
proof incorporating AI. That's interesting. Why don't we talk about some real world examples? I know there's some people out there, some people we like to talk about the tech, but some people have difficulty almost like visualizing all this tech stuff. So can you give me a real world use case like for your applications? What's something that like I would be able to use, in the real world? Just give me an example of how that would work.
let me give you an example for a very big topic. It's like a Federal Reserve. So
Okay.
now, for example, in the Federal Reserve, um, every quarter they have a meeting to increase the interest rate or not. So they have multiple people from different local government. They propose their opinion, so they vote. So actually, you can think about every pupil is a model. It's actually an AI model. So every member gets some sense from the data, either from it could be from social media, it could be from report, very professional third-party reporting, those things. So every people have their own opinion, and then they vote. So this process is actually very similar to an AI decision making and a decentralized AI autonomous system. So in our system, we can simulate this process and make it very, very decentralized. So each AI can have their own inference, and all the reasoning process is public. So now every member, when they vote, the process is actually not public. Okay. Although they can provide some public information, but the decision-making process is not that public. So can we make a decentralized Federal Reserve? That's one big topic. So that's one big possibility. So another thing is, for example, all the new computing scenario interact with the real world. For example, self-driving and robots. All this kind of computing needs video and picture and maybe speech. All this kind of thing is actually AI computing. As long as your digital things want to talk, want to interact with the real things, the bridge is AI computing. So there are a lot of possibilities for the application. For example, the self-driving. So in future, there are already, Tesla have self-driving. In future, every car have this functionality, and every car will learn from their owner the driving behavior. Somebody may be aggressive, somebody is more conservative. So if there's some transaction happening on the roads, now people using carpool, like in California, you have a carpool giving a higher priority for multiple people. But can this happen? Which means if you're in a hurry, you pay micro payments to the car around you to give you a yield. You go first. Then people are talking about this. So this transaction has to be included in the smart contract to guarantee the both benefit from the different party, buyer and the sellers. So this transaction involve, if you are talking about a yielding, is actually a short video. It's a 1 second short video. You do yield to the car behind you. So this thing could be done within smart contract.
That's awesome. That's awesome. Yeah, I mean, smart cars, smart driving, that's definitely something that's going to happen. It already is happening. I think the thing that people don't realize is that AI, people think that it's this crazy thing, but there's AI in the phones. There's AI in everything that we use. It's a pretty general term. I think a better word sometimes is machine learning. It's actually allowing these processes to almost be able, like I envision that, say there's a car and it hits a pothole, right? Maybe it can like send a signal to the car behind it, like, hey, there's a pothole, go around it. You know what I mean? Or to the same car itself. So stuff like that. Those are all real world use cases. And I think that eventually, and I'm sure you would agree, that AI is going to be a very, very big player in a lot of the tech moving forward. As far as the roadmap goes, what are you guys looking, are you guys on schedule? I mean, how's everything going right now? What can we expect from you moving forward?
We have a roadmap on our white paper. In the Q3, we deliver the testnet for the mining part, the Cocoa Cycle things. And in the Q1 in 2019, we have a testnet for the Cortex virtual machine. And in the Q2 2019, we launched the mainnet. So far, we are pretty on schedule, and we are actually a little bit ahead of schedule.
Oh, that's good.
yes, so there's no problem in terms of the delivering the whole thing so far.
Mm. So what do you guys think's been the toughest thing so far? If you had to say what's the most difficult part about this whole process for you guys, this whole journey?
It's very, once we launched the ICO, it's very tired. We have a routine each event conference, and actually it's a little bit distracting. I would say it's a little bit distracting from the development,
Yeah.
but still, since we have enough people to handle that, we have CTO, we have chief scientists to work together to monitor a group of the greatest engineering team to deliver this product. So we are still hiring. Is sort of we are a little bit short of a hand, but it's okay. It's okay. We have like 30 people already in this project, and on their full speed in delivering this product. So
Yeah,
far, it's good.
that's awesome. Absolutely. And I mean, if any, everybody out there watching, community is super important. So, don't hesitate. I mean, I don't, if you guys are hiring, maybe there's some developers out there that are interested that might be qualified. That's
Yeah,
always something to look into. There's
sure,
plenty of positions available. So,
sure.
yeah,
One thing.
yeah.
Let me make some comments. So we have a GitHub repository, and so there are some people asking us why don't make all things public. So we talk to the public. So we will release our code in a way of a delaying method. It's a delay one quarter or 2 quarter, but the big exchange have access to our code, so sign the NDA because nowadays there are too much copycat, copycat things. It's gonna be open source eventually, but we don't want to, during the process, the development, there are too many copycat projects jump into this.
Yeah,
So
that's
that's the
understandable. Hmm.
yeah. But the big exchange, they can access our code and make an audit on
Oh,
our code
all right, cool.
and see.
Yeah. That could have been something that somebody was worried about. I didn't even think to ask that. So thank you for, openly clarifying that. I appreciate it.
Yeah,
There was definitely some deep diving in the middle part. I may have to actually rewatch this again myself to get all of it. So, yeah, that being said, thank you, Ziqi Chen, for coming back to my channel. I really appreciate it. For everybody that's interested out there, definitely check out Cortex. They're doing a lot more than just AI on the surface, but when you dive in, there's a lot more to this project. So thank you again for coming back to my channel. I appreciate it. And to everyone out there, my name is K-Dub. This is Crypto Zombie. Until next time, stay crypto and peace out.
Mhm.